All right, so this is chapter 10, and the whole deal with chapter 10 is how to handle ambiguity in your forecasts. Ambiguity, I mean, like you're not really sure, are sales going to be 1 million or 1.1 million? Are costs going to be, 50% of sales, or are they going to be 45% of sales? So how do we handle that? How do we communicate that to people? That's the real point of this chapter. So this is chapter 10, and we're gonna look at three different tools. The first one is called sensitivity analysis, and this is all based on that spreadsheet with the free cash flows that we did and the NPV calculation. Okay, and so all these three different tools are different things we're going to do on that spreadsheet. Now, on that spreadsheet that we did, when we put in forecasts for like sales and costs and how much the capital investment is going to be, those are all the expected numbers we have in our head. That's what we expect to have to pay. That's the expected revenue we're going to get. Okay? But when we do sensitivity analysis, what we want to do is look at the key assumptions that we're making and then think about a range of potential values we could get. So we go in thinking, okay, sales is going to be $1 million in the first year. And that's what we expect to happen, right? But we're not 100% sure it's going to happen. And so in sensitivity analysis, we come up with a range kind of from worst case, expected, all the way up to best case. Normally, we're going to make our projections on that middle expected case, but we want to also see how sensitive the NPV is if instead of that expected case, we get a worst case, or if instead of that expected case, we get a best case. What happens to the NPV when that single variable assumption is altered? That's sensitivity analysis. You change one variable and only one variable and see what happens to NPV. Okay? And then in scenario analysis, we're going to recalculate the NPV again, but this time we're going to allow multiple things to change all at the same time. And usually this is related to some event. And so, like, for example, let's say we're going to open up a Domino's pizza franchise. But what happens if a year later, someone opens a Papa John's franchise on the same block from us? That's certainly going to affect our sales and profitability, right? So you may want to forecast that as a scenario of a competitor opening up close by to you. In fact, when we go through the example today, the only thing I could think of was one scenario is what happens if a pandemic hits. And so depending on your business, things could not be affected. They could be affected significantly. So that will be that's a situation where multiple things change at the same time. Because think about it, in a pandemic, certainly sales revenue are going to be affected, but maybe SG&A costs are going to go down. Maybe you're not going to advertise as much as well. Maybe costs of buying things is going to be more expensive. Maybe they're going to be harder for you to get. So multiple things could change at the same time, and that's scenario analysis. And the last one we're going to cover probably Wednesday is break-even analysis. And that's basically where you change your sales assumption until you get a break-even NPV, basically when you get NPV equal to 0. Maybe in one of your accounting classes, or if you had entrepreneurship classes, you often calculate the break-even sales number, right? And you may calculate that break-even based on profits. But here, what we do is we calculate that break-even based on NPV. So how low can your sales go until you get an NPV of 0? That's your break-even number for a project. Okay, so let's talk about sensitivity analysis. So in sensitivity analysis, what we do, the first step is to record the worst case assumption for a variable like sales or cost of goods sold, an expected case, and a best case. And we're going to put that all in one table so it's easy for people to read it and understand it. The whole purpose of this is to get a range of NPVs so that we understand how sensitive the assumption is and how that affects our NPV of a project. Again, this is a way to analyze risk, because if we go through like a worst case scenario in sales and the NPV is still positive, then there's not a lot of risk that sales is going to negatively impact our project, right? Because the whole point of this is to look at all our assumptions, all the different variables, and decide where the risk is. And the risk is going to be basically where that worst case scenario turns really, really negative. The next step after we record all those assumptions is to determine the NPV for each assumption one at a time, because we only want to change one variable at a time. Everything else is going to stay as the expected. And so that way we can analyze the impact of one single variable at a time to help us identify where the risk is. And then we're going to record all these NPVs we're going to calculate in another single table to help, again, communicate where the risk is. So here's the spreadsheet setup. And in a minute, I'm just going to switch over to Excel. And I did upload this already, but it's blank right now. And then we will finish it together in Excel. So up here are assumptions that we've made. And notice how there's worst case, best case, and then expected. And I already have the expecteds all filled out. And then and we're going to have to come up with kind of worst case, best case scenarios for the key variables that we want to look at. And then we're going to rerun the spreadsheet with every changing variable to see what the NPV is. And then we're going to record those NPVs over in this table here. So that's the general plan. I'm going to switch over to Excel now. Okay. I did change the spreadsheet a little from what's in the PowerPoint slides. Here are our assumptions. Let's assume the discount rate is 10%. We're going to do straight line depreciation over 5 years of the initial capital investment. And let's also assume that sales is going to grow 4% per year from years 1 through 5. Okay? And here are our expected assumptions. So the first thing I'm going to do is let's go ahead and build out this spreadsheet so we can get it to calculate NPV for us. And then we'll go through and we'll change all these numbers one by one to see what happens to the NPV. And then we'll record that. So the first thing is sales. And for sales, let's see, I'm going to say it's equal to 100,000 right there. Okay. And then to calculate our sales after that, I'm going to try to make each one using a formula so that we don't have to change a lot of things in our spreadsheet. So because of the 4% growth in sales every year, I'm going to say it's equal to the previous year's sales times 1 plus 0.04, the growth rate. And so here, sales of 100,000. Oh, I'm sorry. It's I linked to the wrong thing, didn't I? 75,000. There it goes. And then it grows 4% from 75 to 78,000. Now I'm going to take that formula. I'm going to click on the lower right corner of the box and drag it all the way across. And you should see this growth. Now it's growing 4% every year. And you can see how it shifts all the cells that I mentioned. So in this formula for year 2, it's C13 times 1.04. But then if we go to year 3, you see how it changed it to D13 times 1.04. So when you drag and drop that formula across, it automatically changes the cells, the cell references. Let's record the investment. Investment is 100,000, and I'm going to put that right here. And let's see, there's no salvage value, so we don't have to worry about that. Let's see, what else? Oh, sales are only supposed to go to years 1 through 5. So I'm going to go ahead and delete that. Depreciation. Let's record that right here. So it's straight line over 5 years. So, and because we're going to change our investment assumption, I'm going to link to this number right here. And let's just divide it by 5. So that's how much it's going to be. And I'm just going to set this one equal to that cell, so it automatically does everything in the formula across. There, so that's that should be C6, sorry. Okay, there we go. So $75,000. No, I'm sorry. I'm having a senior moment here. There we go. $100,000 investment spread over 5 years is $20,000 per year, right? That's the depreciation. All right, so we got that. We got the sales number. Now let's do cost of goods sold. So cost of goods sold is forecasted as a % of sales. And that's pretty much a way a lot of spreadsheets go in finance. When we do forecasting, a lot of numbers go off as a % of sales. Cost of goods sold, SG&A, working capital, those 3 things, the 3 big ones you see right here. So this is how we're going to do it. We're going to say cost of goods sold equals the sales number in year 1 multiplied by the cost of goods sold assumption up here. Okay, that should give us cost of goods sold for this year. Now, but check this out. If we just go ahead and copy this over, it's going to give us the wrong number. And the reason is, check out the formula right here. See, we told it to take the sales in that year multiplied by this number up above. But when we copy it over to the right, it's going to keep looking right above our sales number. So that means we have to change something over in year 1 here. And we do that because, right, this cost of goods sold assumption, we want every single year to point to that same cell. So we want, that's right, absolute cell reference. So what we don't want the formula to change from sales times D7 and then in year 3 sales times E7. We don't want it to keep moving that across. So the way to fix that is to put a $ in front of the column letter. What I did right there. Now watch this. The $ makes it so it stays where it is at C, and Excel won't automatically change it. Now watch this. So now when I click on this, look, it still says, it changes the sales to year 2 sales, but it still says C7 over here. Look at this over here. it changes it to year 5 sales right here, G13, but because of that dollar sign on C7, it's still looking back here for the assumption on cost of goods sold. So that's how we handle when we have assumptions going up, up to a certain part, and we want to keep them constant. Now we're going to do the same thing with SG&A. SG&A is a percent of sales. So we take sales multiplied by SG&A percent assumption right here. But because that assumption is only in one spot and it doesn't go all the way across the spreadsheet with each year, I'm going to put a dollar sign. So Excel won't change the cell reference when we copy it, when we drag and copy it. There we go. Now we can go ahead and calculate EBIT, right? EBIT's just going to be sales minus cost of goods sold minus SG&A, right? And so we can just drag that across as is because we want Excel to recalculate it for each new column that it's in. So here we see it changed to D13, 14, 15. And if we go all the way over here, it's G13, 14, 15. So that saves us a lot of time. All right, now I'm going to go ahead and calculate taxes. And taxes are 35% of EBIT. So now normally the tax rate, maybe I should have put as an assumption up above, but I did not in this case. So it's going to be 0.35 times EBIT. And we can drag and drop that one all the way across. And you can see here in the last year, it's still 0.35, but now it's times year 5 EBIT. Okay, we've got depreciation all done. Now we have to do working capital. All right, so working capital, it's also a percent of sales, so it's going to be equal to sales multiplied by this working capital expressed as a percentage of sales. So sales times that 15% should give us the amount of working capital every year. So that's 11,250. Let's put a dollar sign in front of the C so that we can drag it across the formula without changing the cell reference to C9. Okay. Year 0 is going to be 0 working capital, just so we have that in there. Now let's go ahead and calculate the change in working capital every year. And it's basically like we did before, the current year minus the previous year, right? And let's go ahead and take working capital to 0 the last year. So that kind of represents a recovery of working capital, like selling off all the inventory that we built up and getting collected on all the accounts receivable, that kind of thing. Okay, so we have that. We got capital investments, salvage value. Now we're ready to calculate free cash flows. I know this can be kind of long and tedious, but this really is the work of a financial analyst, and putting all these spreadsheets together is a significant part of the job. And I guess you know whether or not you like it, right? To me, it seems like a big jigsaw puzzle. So it's kind of fun doing this. You guys don't realize this, but I just love the last 45 minutes we've been doing spreadsheets. All right, so let's go ahead and plug in the formula for free cash flows. We know that it's, and again, we're going to do it in year 0, and it's going to include everything we could possibly put in the formula so that we could then drag that formula and copy it all the way across through every year. So that's kind of the goal. So it's EBIT minus taxes. And I know it's 0 right here, but later on, right, when we copy the formula across, it's going to do the same thing for every single column, so it'll still work. EBIT minus taxes, and then we plus depreciation, right? And then we subtract the increase in working capital, and then we subtract capital investment. And it doesn't look like we have to worry about salvage value, so I'm not going to do anything with that. Okay, so year 0, free cash flows are basically just capital investment, so that looks right. Let's go ahead and select the formula and then drag it across. And so those are our cash flows. Why do we have a positive number here in year 6? Oh, because we have a negative change in working capital, right? And in the formula for free cash flows, we subtract the increase in working capital. And if we subtract a negative increase, it's like two negatives, they form positive. So that's why year 6 is actually positive cash flow. And if you think about it, it makes sense because, right, we're selling off our inventory that we built up. And so that should produce a positive cash flow. Any questions on the spreadsheet so far?
What's the difference between the free cash flow formula and the EBIT?
The free cash flow formula uses EBIT. So EBIT is just a small part of the free cash flow formula.
Can you go over the EBIT thing? The EBIT.
Okay, hold on a second. So here, EBIT is basically going to be sales minus cost of goods sold and minus SG&A. So that's earnings before interest and taxes. Sometimes, depending on the company, it's the same as operating income. So you may be used to hearing operating income or operating profits. It's pretty similar to that. The point is, for us, we want the income before interest from financing, right? Because we're not looking at financing costs. That was one of the early things we said about free cash flows. We're not going to look at financing. Interest expense is a financing cost. Okay, so we're not going to look at that. And that's why we take it out before interest. Earnings before interest. And then here's the formula. It's basically sales minus cost of goods sold minus SG&A. Does that answer your question?
Yep. Yeah. Is SG&A general and administrative?
Yeah, sales, general, and administrative expenses.
Okay.
Those are basically expenses that cannot be tied to the cost of goods sold. You know, it's like if you're building cars, SG&A, it's not the steel that goes into the car, it's not the paint, it's not the robots, it's not the labor charges for people building a car. SG&A is like headquarters, it's marketing, that kind of thing. Those are overhead costs that then later get kind of smeared over all the products because you can't identify which particular product they go with. That's the CEO's jet plane. That's for SG&A. That's what SG&A is.
See. Also, the discount, I'm not sure if we used the discount yet.
No, we're going to use that when we get to NPV.
Okay.
Yeah. All right, so let's go ahead and calculate NPV. So it's basically year 0 cash flows. We don't put that in the NPV formula, right? And then for year 1 and onward, we're going to go put in 0.1 for the discount rate. And then we put a comma between every year's cash flows. And that right there should calculate NPV for us. Hopefully it's positive. Just barely, 42,000 positive. All right, wow, it took us a little while to get there. The next step for us is to start going through these assumptions and then seeing what happens to NPV when we change these assumptions. So let me give you an example here. Let's look at the capital investment in year 0. And let's say that you got a bid to build something. I don't know, maybe a new office building, or, well, maybe not for $100,000, but let's say whatever it is you want to build, you expect it to cost $100,000, right, in year 0. But then you do some research and you ask around, okay, what could happen is, let's say they're building some house and they find, there's not solid ground underneath, and you weren't expecting that at all. So maybe, you know what, let's forecast that we could be 20 or 30% over budget if something goes wrong. Okay, so let's forecast $130,000 as a worst case. And then in a best case, let's say, we could save a little bit money because we do have a little contingency built into that 100,000. So if everything goes right, it might only cost us $90,000. So this is a range of values that we think we're going to see. Not 100,000 is what we expect, but it is possible something goes wrong. And so this range of potential outcomes is basically risk for us. So what I'm going to do now is I'm going to go through and I want to recalculate the NPV, assuming this difference in capital investment right here, okay? So first thing is, let's change it from 100,000 to 130,000 and see what happens. So I'm going to go in the spreadsheet right here. I'm going to say, okay, this equals this right here. I don't have to change anything else. I'm only changing one thing. That's sensitivity analysis. And now my NPV goes to 12,583. I'm going to go ahead and record that right here, 12,583. Now, basically what I'm going to do is do the same process for these different variables, and then we can look at this table of NPVs and we can decide where the risk is in the project. And the risk is where the worst case is gives us the lowest NPVs. Those are going to be where the risk is going to be. We'll change this to best case up here too. And that's 52,583. And now we're going to change it back to the expected case right here, because we only want to change one thing at a time. And I'm going to put that number in, 42,583. So there we have a range of NPV values based on the range of capital investment assumptions. Let's do the same thing for sales. So let's say sales, worst case scenario, let's say it's $25,000. And best case scenario, let's say it's $100,000.
I have a question. For the investment in year 0, did you switch up the 130 and 90? Because wouldn't the 130 be under best and then the 90,000 would be under worst? Or is it not that because it's an investment?
Yeah, it's a negative cash flow.
Okay.
So the way I figured it, if it costs a lot more than you think it did, that's kind of a worst case scenario. So
Okay.
it does get flip-flopped, right?
Yeah.
I've done this enough. It's just natural to me, right? So I apologize for not explaining that.
Oh, no,
So,
it's
yeah,
okay. That makes
because
sense.
you're right, though. Capital investment is a negative cash flow. So worst case is it's going to be really high capital investment.
Definitely, yeah.
But sales is the opposite, right? So the worst case sales is going to be a really low number.
Yeah,
Yeah, that's right.
that makes sense.
All right, so now what we want to do is we're going to change sales to this number right here, 25,000 worst case, calculate the NPV, and then put it right over here. Then we're going to change sales to the best case, 100,000, calculate the NPV, and then put it right over here. That's our strategy. So sales right here. Let's go ahead and change that here. And now because the way we plugged in the formulas, it should carry through the entire spreadsheet. You see that? So we've got a negative 1,928. Now let's go ahead and change that to the positive, the best case up here, and 64,839. And then we go ahead and we change that back to the expected case, right? And again, we get 42,583. In fact, we can just copy this expected. It's going to be the same all the way down. So it's going to be like that. Let's just do. I'll do one more, and then I think you kind of get a feeling for what we're doing here. So cost of goods sold, that's a cost, right? So worst case scenario, cost of goods sold is going to be higher than what we expected. So let's say it's 50%. That's our worst case scenario. And best case, we think, it could be maybe 43% of sales. Okay, so let's go ahead and calculate, assuming cost of goods sold is 50%. Now let's double check how I wrote the formula. You see how they all go to cell C7? So that means I could have wrote it better probably, but all right, so I'm going to have it go to B7. Yeah, I didn't write that well. I had to change all my formulas. That wasn't good. But let's record the MPV. So the MPV now is 33,046. Okay, so that's still positive. And now best case scenario for cost of goods sold is 43%. So let's go ahead and change that again. So now it's going to point to cell D7, right? And I'm going to have to change that formula all the way across because the way I wrote it. And now our NPV is 46,995. Okay, now I'm going to go ahead and switch this back to cell C7, the expected case, and then make sure that gets copied all the way through there. And we get 42,583. Oh, look how this copied here. That's funny. All right. Yeah, that happens sometimes when you're doing numbers. There we go. So that's the process, and we could do the same with SG&A, and then we could do the same with working capital. Which ones you do kind of depends on the project and what the key assumptions are. So like, let's say you were building some new real estate development or building a car wash or something, you know, going through the permitting process could be a major assumption in terms of when you're able to start operating your business. Maybe you get all your permits in 3 months and you can open up for business in 5, but maybe you get stuck in it for a year, going back and forth and negotiating with the town that you're trying to build in. So the assumptions that you test for sensitivity analysis really depend on the project, and there is no right formula. It's more of an example of identifying what those assumptions are in your project that could impact NPV. And then once you've done that, you go back and you ask people who maybe where you got the assumptions from and ask them for a range of potential outcomes, worst case to best case. Run those through your spreadsheet and then come up with this table of NPV values. And now we can start thinking about where is the risk in this project. And so if you look at this, where do you think the risk is in this project?
Sales.
Exactly, sales, right? So we could just say, you know what, I'm okay with that risk. Let's roll the dice and we're going to go with it. Or you could also go to where you got your sales forecast and you could ask them to do a little bit more research to see if they can tighten up their forecast to try and see if there's something we can do to minimize this risk right here. Maybe they'll say, you know what, why don't we do an advertising campaign when it first opens up to help generate sales faster? Maybe that's something we built into the project then. And maybe that reduces the risk of really low sales the first year. So that's kind of how you would approach it. You look at this table, you kind of see where the negative risk is, it's in sales, and you have a discussion about, is there anything we can do about it? Or should we just kind of roll with it and just take the risk as it comes? On the best case side, you can also look here and maybe there's something like, wow, you know, the big upside here is in sales. And so if we can get a lot more sales that first year, it really increases our NPV. We should definitely look at some type of advertising campaign to help generate demand, right? So that's kind of how this table and the sensitivity analysis would be used. All right, the next one's called scenario analysis. This is the last one for today. And this is, it's similar to sensitivity analysis. We're going to change, except we're going to change multiple assumptions, and then we're going to see what the impact on NPV is. So it's called scenario analysis because they want you to think about kind of like a perfect storm. Like if X happens, all these different things are going to change, and they're all together going to impact the NPV. And so we call that a scenario. And so let's go ahead and look at one scenario on the spreadsheet. Now, for a lack of creativity, I just came up with a pandemic scenario. Sorry about that. It was the only thing I could come up in my mind at the time. So let's just say for this business, we want to come up with brand new assumptions for each of these 5 key things. And we think that during a pandemic, not just one thing will change, but multiple things will change, okay? So let's say the investment, let's look at that. You know, it's all happening at year 0. So I'm thinking maybe we think the investment's going to be about the same. So it hasn't happened yet, and we'll get it in fast. Now, certainly sales in year 1 are going to be affected, right? So then you would kind of have to hypothesize what could sales be in a pandemic? And obviously it's going to depend on your business, right? Home Depot did pretty well. Amazon did pretty well. But, you know, a lot of the entertainment stuff has really been hurt, right? Movie theaters, restaurants. Why don't we say, excuse me, why don't we say that sales goes to $30,000. Oh, I said this was expected, right? 1, 2, 1, 2, 3. So that should, okay. Cost of goods sold. Is it possible our cost of goods sold would go up? I'm going to say not. So I'm going to go with the original assumption there. But I'm going to say SG&A is going to drop. Maybe we're going to do less advertising. Maybe people aren't going to be working in the office as much. So let's say SG&A drops to 15%. Working capital. You know, I'm going to say working capital might go up because maybe we have people who don't pay us as much as quickly as before. So our accounts receivable might go up. So let's just say accounts receivable, let's say it goes up to 20%. Okay, so we changed multiple things here. And again, I just kind of pulled this stuff out of my pocket just for the sake of, you know, looking at an example. But this is my first guess in terms of how it would affect assumptions. So let's go ahead and change everything now in our spreadsheet. So the first thing is capital investment. And that's the same at $100,000, so we don't have to change that. But then sales is going to change, right? So I'm going to go ahead and change sales to over here. And we see that flows through all the way. Now let's go ahead and change, let's see, cost of goods sold doesn't have to change, that's the same. But SG&A is going to change to 15%. So let's go ahead and change that. This equals, I'm going to change the cell reference to cell J8 over here. Hit enter. And then I'm going to go ahead and copy that all the way through. EBIT doesn't have to change. Taxes is all good. All that's built on formulas. Depreciations is still built on the capital investment of 100,000, 5 years. Working capital is going to change. So instead of going to cell C9 here, let's point it to cell J9. So we got more working capital. Now I'm going to go ahead and copy that formula over. Okay. I think that's it. So there's our NPV, 5226. It's a lot lower than the expected case of 42583, but based on this particular business, we're still slightly positive. So that's how you would do scenario analysis. Change multiple things at the same time and see what effect it has on NPV. So that's all we have for class today, everybody.